Good morning, good afternoon, good evening. Welcome to the application of GIS in conservation online course. My name is Eric Wabwile. I am a GIS biodiversity ecosystems expert, and I'll be taking you through introduction to GIS and remote sensing. First, I'll begin with the definition of GIS. GIS is an acronym that refers to Geographic Information System. It is a computerized system that is able to handle spatial data. Spatial data refers to location data that has location components, and the location can refer to either relative or absolute location. Absolute location is given by latitude and longitude coordinates, and relative location is given by another location that is already known. So remote sensing, on the other hand, refers to the method of capturing information of an object from a distance. In GIS, remote sensing is a method of data capture, and the remotely sensed data in GIS is a source of GIS data. So allow me to go to the benefits of GIS. GIS has many benefits, which I have summarized into 4. The first benefit is maximizing the efficiency of planning and decision making. GIS is referred to as a decision support tool. So it is able to give insights that guide decisions. The second benefit is integrating information from multiple sources. GIS is able to integrate information from the various sources and is able to give you insights based on those information. The third benefit is facilitating complex querying and analysis. GIS is able to query and give information. So you can query the database and give you geo information that can help you to make decisions. And lastly, GIS is able to eliminate data redundancy and minimize duplication. It uses what we call a primary key, which can be used to minimize duplication in a GIS database. As I told you, GIS is a system, and therefore, like any other system, it has components. It has 5 components. The first one is hardware, the second is software, the third is data, the fourth is people, the fifth is procedures. So I'll be going through each of these components into details. The first one is hardware. Hardware refers to equipment and devices that are used in GIS. These are devices that are used to either capture, process, store, or visualize geographic information. It could include computers, hard disk, digitizers, scanners, printers, plotters, and so forth. The second component is software. Software refers to programs that are able to handle spatial data. This software can be categorized into 2. We have what we call commercial software, and we also have what we call free and open source software. Commercial software refers to the software whose source code is kept private and only the owner has legal rights to modify or distribute it. On the other hand, free and open source software refers to software whose source code is provided to the users, and the users have permission to modify it in whichever way they want to meet their needs and demand. So I have a presentation with the more comparison between commercial and open source software. You can explore and learn more about the 2 types of software. But I'll go to the third component of GIS, which is spatial data. We also call it geographic data or GIS data. This is data that has location component, and it has 3 elements. The first element of geographic data is what we call geometry. So geometry refers to shape, size, and location of features. Then the second element is called attributes. It refers to descriptive information of features. And the third element is what we call metadata. Metadata refers to data about data. It is information that describes the characteristics of a GIS dataset. It can include the title of the data, the description of the data, the author or the creator of the data, the date when it was captured, and the coordinate systems and any other information that describes that particular data set. Then we go to the fourth component, which is people. People, as a component of GIS, refers to individuals and even organizations who either develop the GIS hardware or GIS software, or those people who use the GIS system. So we have people can be categorized into two, as users or developers of the GIS system. Lastly, we go to procedures and policies. This is the fifth component. Some call it methods. In GIS, we are guided by policies and procedures. Policies ensure that either we capture data that is of high quality, or we maintain the standards of the processes and methods that we use to process GIS data. It could also include manuals and frameworks within which we operate with the GIS, or we interact with the GIS system. So those are the five components of GIS, and now we can go to the functions of GIS. GIS has 4 functions. The first function is data capture and preparation. The second is data storage and management. The third is data analysis and querying. And the fourth is data presentation. So when we talk about data capture, this entails the processes and methods of data acquisition, such as surveying, photogrammetry, remote sensing, and digitization. Remote sensing and photogrammetry capture data in form of images, which now forms are data sources within the GIS system. And from these images, we are able to derive GIS data. Surveying, on the other hand, refers to collection of information from the position of the objects. It is used to collect socioeconomic data, or even to collect coordinate information of features. We also have another method of data capture, what we call digitizing. Digitizing as a method of data capture involves capturing features from analog data sources. And it has various steps. For example, if you have a hard copy map, first you have to scan the map, and then you can georeference it, and then you can digitize information from it. We can go to the second function, data storage and management. Data storage and management as a function, it involves storing geographic data, either within a database, or what we call a spatial database, or in a folder system. So depending on the type of data, it can be stored in a geodatabase or a folder system. For example, we have what we call analog. We have what we call vector data, which is normally stored in a geodatabase, and raster data is normally stored in a folder system. So data storage in GIS can be stored in form of layers. You can store your data as in thematic levels, or you can use scale. Scale is when you store your data based on the coverage of the data. For example, you can store national data together, and then you can store local data together. Or we can store global data together and store regional data together. So that is all about data storage and management. Data analysis and manipulation refers to deriving new geoinformation from a stored GIS data. It includes functions like spatial analysis, network analysis, image analysis, and all other types of analysis that we perform on the GIS data. And that is all about GIS functions. Now we go to the coordinate systems and map projections. Coordinate systems and map projections are part of the location information of the GIS data. So first we have what we call map data. A map datum is a reference point of a surface upon which measurements are made on the Earth's surface. So there are two types of map datums. We have vertical datum, which is a reference surface for elevation data, and the horizontal datum, which is a reference surface for planimetric measurements. Then coordinate systems refers to a reference system used for locating objects either in 2 or 3-dimensional Earth. We have two types of coordinate systems. We have geographic coordinate system, which is used in referencing objects using the 3-dimensional Earth, and we have projected coordinate system, which uses the 2-dimensional Earth to represent features on Earth. So with that, thank you so much, and see you.